Rigid non-metallic conduit, also known as RNC, is permitted for underground installations according to the National Electrical Code (NEC). However, some authorities having jurisdiction (OJs) may forbid its use altogether, including outdoor applications. This is generally based on concerns regarding the durability and mechanical integrity of RNC when buried. While the NEC permits RNC in underground installations, it also grants AHA the authority to make exceptions based on specific conditions or locations. In areas with harsh soil or a high risk of physical damage, the AHA may prohibit RNC. It's crucial to verify the local AHA-specific requirements for underground electrical setups. If RNC is not allowed, alternative conduit types like polyvinyl chloride (PVC) or high-density polyethylene (HDPE) must be used. Some reasons why AHA restrict RNC underground are: firstly, mechanical damage. RNC is more prone to mechanical damage than PVC or HDPE because it is made of a rigid material that can crack or break under excessive force. Secondly, soil conditions. RNC isn't as resistant to soil acids and alkalis. In harsh soil environments, RNC can degrade and become brittle over time. Thirdly, freezing temperatures. RNC resistance to freezing temperatures is lower compared to other conduits. In areas where the ground freezes, RNC may become brittle and develop cracks. When planning underground electrical wiring, always consult the local AHA to understand their specific regulations. If RNC is not approved, select an alternative conduit that complies with the AHA requirements. Let's delve deeper into these factors. Considering mechanical damage, underground conduits can be subjected to various stresses. These include the weight of the soil above, the impact of rocks or other debris during backfilling, and potential damage from digging or construction activities in the vicinity. RNC, being more rigid than PVC or HDPE, lacks the flexibility to absorb these impacts without cracking or breaking. PVC and HDPE, with their greater flexibility, can often withstand these stresses without sustaining damage. This difference in mechanical strength is a primary reason why AHA might prefer the use of PVC or HDPE in underground applications. Regarding soil conditions, the chemical composition of the soil can significantly affect the longevity of buried conduits. Soils can contain acids, alkalis, and other corrosive substances that can degrade certain materials over time. RNC, while resistant to many common chemicals, may not hold up as well as PVC or HDPE in highly acidic or alkaline soils. PVC and HDPE are known for their excellent resistance to a wide range of chemicals, making them a more reliable choice in such environments. The specific type of soil in a given area is a critical factor that AHA consider when determining the suitability of RNC for underground use. With freezing temperatures in regions where the ground freezes, the expansion and contraction of the soil can put significant stress on buried conduits. This is known as frost heave. RNC, being a rigid material, is more susceptible to cracking under these stresses. PVC and HDPE, with their greater flexibility, can better accommodate the expansion and contraction of the soil without sustaining damage. The depth of the frost line in a particular area is a key consideration when selecting the appropriate conduit material for underground installations. AHA will often take this into account when deciding whether to allow the use of RNC. Beyond these primary factors, there may be other considerations that influence an AHA decision regarding the use of RNC underground. These may include the specific type of installation, the depth of burial, and the presence of other utilities in the area. For example, in areas where there is a high concentration of underground utilities, there may be a greater risk of accidental damage to conduits during excavation. In such cases, AHA may prefer the use of a more robust conduit material such as PVC or HDPE. The cost of materials and labor is also a factor that may be considered. RNC is generally less expensive than PVC or HDPE, but the increased risk of damage and the potential for premature failure may outweigh the cost savings in the long run. It's also important to be aware of the specific requirements of the NEC regarding the installation of underground conduits. The NEC provides detailed guidelines on the depth of burial, the type of backfill material to be used, and the spacing between conduits. These guidelines are designed to ensure the safety and reliability of underground electrical installations. When planning an underground electrical installation, it's always best to consult with a qualified electrical contractor and the local AHJ to ensure that the installation meets all applicable codes and regulations. A qualified contractor can assess the specific site conditions and recommend the appropriate conduit material for the application. The AHJ can provide guidance on local requirements and any specific restrictions that may be in place. Ignoring these requirements can result in costly repairs, delays, or even safety hazards. Furthermore, the NEC outlines specific requirements for underground installations in Article 300.5. This section covers minimum burial depths, protection from damage, and wiring methods suitable for direct burial or encasement in concrete. It is important to know that the minimum burial depth specified in Table 300.5 may vary depending on the voltage of the circuit, the type of wiring method used, and the location of the installation. For example, direct burial cables typically require a greater burial depth than conduits encased in concrete. In addition to the NEC local codes and regulations may impose additional requirements for underground electrical installations. These requirements may be more stringent than the NEC and may vary depending on the specific jurisdiction. It is essential to consult with the local AHA to determine the applicable requirements for your project. Proper installation practices are crucial for ensuring the long-term reliability and safety of underground electrical installations. This includes using the correct type of backfill material, compacting the soil properly, and avoiding sharp bends or kinks in the conduit. It is also important to protect the conduit from damage during installation. This can be achieved by using appropriate bedding materials and avoiding the use of heavy equipment in close proximity to the conduit. Regular inspections and maintenance can help to identify and address potential problems before they lead to failures. This includes checking for signs of damage, corrosion, or settlement. It is also important to ensure that the grounding system is properly maintained to prevent electrical shock hazards. Understanding the differences between various types of conduit is crucial when selecting the appropriate material for an underground installation. PVC conduit is a popular choice for underground applications due to its excellent resistance to corrosion, its flexibility, and its relatively low cost. PVC conduit is available in various sizes and thicknesses, and it can be easily cut and joined using solvent cement. HDPE conduit is another common option for underground installations. HDPE conduit is known for its high strength, its resistance to chemicals, and its ability to withstand extreme temperatures. HDPE conduit is typically used in applications where a high level of protection is required, such as in industrial or commercial settings. Rigid metal conduit, RMC, is a more expensive option than PVC or HDPE, but it provides superior mechanical protection and is suitable for use in areas where there is a high risk of physical damage. RNC is typically made of steel or aluminum and is available in various sizes and thicknesses. Electrical metallic tubing, EMT, is a lightweight conduit that is typically used for above-ground applications. ENT is not suitable for direct burial or encasement in concrete due to its limited mechanical strength and its susceptibility to corrosion. Flexible metal conduit, FMC, is a flexible conduit that is typically used for connecting electrical equipment. FMC is not suitable for direct burial or encasement in concrete due to its limited mechanical strength and its susceptibility to corrosion. In summary, selecting the appropriate conduit material for an underground electrical installation requires careful consideration of the site conditions, the applicable codes and regulations, and the specific requirements of the project. Consulting with a qualified electrical contractor and the local AHA is essential for ensuring a safe and reliable installation. Remember to always prioritize safety and adhere to all applicable codes and regulations when working with electricity. Electricity can be dangerous, and improper installation practices can lead to serious injuries or even death. By taking the necessary precautions and following best practices, you can ensure that your underground electrical installation is safe, reliable, and code compliant. Always remember to double-check local codes because they might be amended at any time. Furthermore, consider the long-term implications of your conduit choice. While RNC may seem like a cost-effective option upfront, the potential for premature failure due to mechanical damage, soil conditions, or freezing temperatures could lead to costly repairs and replacements down the line. Investing in a more durable conduit material, such as PVC or HDPE, may be a wiser decision in the long run. Finally, always document your underground electrical installations thoroughly. This includes creating detailed drawings showing the location of the conduits, the type of conduit used, and the burial depth. This documentation will be invaluable for future maintenance and repair work. By following these guidelines, you can ensure that your underground electrical installations are safe, reliable, and code compliant for years to come. Understanding the specific concerns and regulations in your area is paramount to a successful and safe electrical project.